My name's Mark Summerfield. I'm an ex-troll. I co-wrote both the official Qt textbooks, and I now work as an independent trainer and consultant. I have really liked the model view architecture that was introduced in Qt4. And if any of you went to Bo Torson's talk yesterday, which I went to, very interesting, don't worry, I cover very different material from what he covered, so there won't be much crossover at all. What I'm going to do is provide an overview of the model view architecture because it's still unfamiliar to many developers. And the emphasis of my talk is on delegates. So naturally I thought I'd start by telling you how to avoid using them at all, or at least how to avoid creating your own. And I'll do that very briefly. I'm then going to show you a simple custom delegate. And the custom delegate I'm going to show you is designed and coded pretty well in the way that the documentation recommends. Then I'm going to say why that might be a problem for you, why it can lead to lots of duplicate code. And I'm going to show you a different approach to creating delegates that will avoid lots of code duplication and that I think will lead to easier to maintain model view applications. Okay. Now, model view or model view controller came from the Smalltalk world, and it's a very simple idea, but I think quite a brilliant one, of separating data from the rest of the application. And the separation is achieved by having a data model. So your data set may be a database, it may be a file, and it may change. But the only code that needs to change in your application is the model, because that's the only thing that talks to your data. Another benefit of this approach is that the model will only ask for the data it actually needs to display, which is typically a very small subset of all the data that's available. So it minimizes traffic over a network if you've got a client-server database as your data set, for example. Now, in the diagram, I've only got one view, and the view is usually some class in Qt. It might be QTableView or QTreeWidget or something like that presents data. And I've shown one, but you can have any number of views associated with the same model, displaying from the same data set, but perhaps different parts. And if you've used, for example, Excel, you've probably at some point done window split to look at two different parts of a spreadsheet that is just physically so distant that you can't see them on the screen at the same time any other way. I'm not going to talk really about the controller. It's a way of giving the user access to manipulate the data, because I'm going to talk about the Qt way. Whoops, sorry. Now, Qt uses model view delegate, and it's a slightly different approach. And Qt provides you off-the-shelf components. It provides subclassable abstract models and views that you can use as your base classes, and it provides some concrete classes that you can use as well. But in Qt, the delegate is something a bit special because it has access both to the view and the model, and that gives it incredible flexibility in how you use it, as we'll see shortly. I'm going to come back to this slide in a moment and tell you some lies. But first I want to talk about, in a sense, the heart of Qt's model view architecture, which is the model view index. Now, this is a class that represents an item's position in a data set. Okay? Now, if you've come from the database world, as I have, you're used to thinking of rows and columns, and with rows being records and columns being fields. But the Qt implementation takes a rather purer approach, and it just deals with items. Now, very often, if you're using tabular data, records and fields map directly to the rows and columns that Qt uses. So it's quite an easy transition. But if you're dealing with hierarchical data sets, you have to work in a different way. And I've heard quite a few people in the conference saying the model view architecture is hard. I think it does require a bit more effort to start with, but I don't think it's hard if you're dealing with lists and tables. But I do think it's hard if you're dealing with trees, because then you have to have a different way of thinking. If you're dealing with a list or a table, things are very concrete. What position are you at in a list? That's your row number. It's very direct. In a table, what's my row, what's my column? It maps directly to model view. But if you apply that kind of thinking to tree models, you're going to get into performance difficulties, because in trees you need to think recursively. You need to think not where am I in the whole hierarchy in terms of rows, columns, or anything like that. You need to think what is my item or what is my item's parent, and you need to walk up and down the tree at the point you're interested in. So it's a different way of thinking. Okay? Now one of the great things, and there are many about Qt's model view architecture, is that it provides a uniform means of access. So you have a data method to retrieve data and other information, and a set data method to set data back into the data set. Now, set data will work whatever the underlying data set is, database, file, whatever. And I think that's a very powerful abstraction to use. But I'm going to go back a slide and tell you a few fibs, a few lies. I'm going to tell you lies about how the view and the delegate work together. And the reason that I'm telling you these things that are untrue is because I think they're actually useful as a way of thinking about how it works, even though that may not be how it really works. A view, in my fictional world, has responsibility for the big rectangle and for the scroll bars. And the view has responsibility for the rectangles that are going to show you the items. But it does not take responsibility for the contents of those rectangles. So it chooses where those rectangles are, what size they are, okay? And it can get information like size hints from the model about what size they'd like to be. But whenever the view wants to present an item of data, it says to the delegate, here's the model index, so row, column, and possibly parent, and you show the data, here's the rectangle which you've got to show it in. And the delegate then talks to the model and says, okay, what's the data I've got to show? What color is the foreground, the background? What font do I use? And other information. And it uses that, and then it paints on the rectangle it's been given. Okay? Similarly, when the user initiates editing, for example, they press F2 or they double-click or they do whatever you've chosen to initiate editing, the view, again, doesn't do the work itself. It says to the delegate, I've been asked to edit the item with this model index. You handle it. And the delegate typically will say, OK, I will create a Q-line edit, and I will give it back to the view. And the view will say, OK, I'm going to take that line edit, I'm going to resize it and position it right over the top of where the item is. So it looks to the user as if magically they've pressed F2 and suddenly they've got a cursor. And it looks as if it's like all blended in. And in fact, it's an illusion because the line edit's on top, but it's exactly on top, so they can't see the difference. The editing takes place, and if the user hits escape to cancel the edit, fine, the view will just delete the line edit and throw it away. If they say, yes, I want the edit, they press return or they click somewhere, then the delegate will be asked, put that data back into the data set. Okay? So that's a fictional view of how it works, but I find it a useful way of thinking about how these things work. Okay, so we've seen what a QModellndex is. Now, you can have a lot of control over the appearance of data without using a delegate. But I better mention one thing that I did forget. Every view provided by Qt has a delegate by default. So you don't have to create them yourself, but they're always there. Okay, so if I talk about not having one, what I really mean is not having your own custom one. Now here, I haven't created a custom delegate, and yet I've got, I don't know how well the colors show up for you, but each category is colored differently. So the kitchenware category has, I think it's a sort of purple background color, whereas the stationery is yellow and the tools are some sort of pale blue. Okay? Now that is achieved without using a delegate. It is achieved by re-implementing the data method, which will, to purists of model view, seem a bit strange, but it works perfectly well. So I've colored according to category. The alignment I've chosen according to column. And the weights actually have different colors. If you look at the 45 grams and 65 grams, they're one color, the 2,500 grams is another, and the rest another still. So you can really control the appearance of data beautifully just by re-implementing data. And I will show you the code so you can see how that's done. I could have been much more extravagant. I could have changed fonts. I could have done all sorts of things. But I just wanted to use these simple colors to give you a hint as to how that works. Now, here's an extract from the code. Now, if you've done any model view programming before, you will have implemented a data method. And normally, the data method is asked to return data for an item with a particular model index and with a particular role. And normally, if you just ask for data to display, the role is the display role, which is the first if statement up there. And in that case, you say, OK, well, what column are you interested in? And here's your data. Now, I've made a choice here. I've decided to return weight as a string that I formatted myself. I'm not convinced that that's necessarily a good approach, but it's easy, and it worked for just read-only data, as I've got here. We will get on to editable data, of course, later. For background role, you just add another if clause to account for a different role, and you choose the criteria. In my case, I use the criteria of what category, and depending on the category, I choose a color. The reason I have the long QObject TRs is because this class isn't a QObject subclass, so I had to do that. Now, I'm not going to show you the code for coloring the foreground for weight, because I think that's enough for you to realize how to do it. You just look for the role equals foreground color role, and you say if the weight is this, below this, then one color, above this, another color, otherwise it's the third color. So I don't think that's hard to do. Whether it's a good place to do it, some people dispute, but it works quite easily, and it doesn't require you to do anything other than what you do anyway, which is create a custom model, because most of the time we create custom models in practice. Okay. Now, I'm now going to show you a standard custom delegate done the way that the trolls recommend, but I thought I'd show you it without the delegate first. So here we have a survey. It has questions in the first column, which must be read-only. We don't want the user to change the question. And then it has their answers. But unfortunately, the answers are coded as integers, which is not very meaningful and not very helpful. So we need to present those in a meaningful way. And for that, we're going to use a custom delegate. So what we want to get is this. We want texts, and when the user initiates editing, with F2, for example, we want a combo box of the valid choices. This guarantees, firstly, that they can only choose valid data, and obviously it's much more convenient for the user and understandable. Okay, so how do we implement something like that? Well, before I look at the implementation, I just want to show the usage. We create a model, and it's very, very typical that the model is our own custom model. We then create a view, and again, it's very common we use one of the standard views that Trolltech provides. It's rare that you have to create new views. So we set the model on the view, but the next line, the fourth line down, is a bit different. We create and set an item delegate. Okay, now I've given it the unlovely name IntString delegate because it's mapping integers to strings. Okay, the first argument is a map which is this map at the bottom of the screen. Okay, it's a simple Q map. It maps integers to strings. Okay, and obviously those strings could be in any language. The second argument is, I think in some ways more interesting. I'm giving it a set of column numbers to which this delegate is to apply. Now I've given it numbers 1, 2, 3. So I'm saying column 0 is none of this delegate's business. All right? So by default, nothing will happen if the user tries to edit column 0. The structure of the QItemDelegate. Now this structure we're going to see many times throughout the talk. And that's because all of the things we're going to create are going to be QItemDelegate subclasses. All of them have constructors. Some of them we'll see will have destructors. And all of them will offer 4 methods. We'll see the signatures of the methods later on. The paint method is called when the view says paint an item. Create editor is called when the user initiates editing to give an editor to the view. If an editor is indeed created, i.e. the view gets a non-zero editor back, then set editor data is called, and presumably that will retrieve the data for the current item that's being edited and put it in the editor in some form. Set model data is called if the user accepts their own edit. They hit return, they click somewhere, basically do anything except press escape. Okay? And what we've stored in our map is just the map of integer strings that we're interested in for our combo box and the set of columns that we care about in this particular example. The paint method can paint in two ways. You can either just take the paint of your past and paint directly, and I think we'll see that later on, or you can use the convenience methods. Now in this case, what I've done, the first column, the first statement is something we're going to see a lot of. If the column you're asking about is not one of the ones I'm responsible for, then the base class handles it, I'm not interested. Yeah? And we'll see more of that later on. But if it is one of the columns we're interested in, either columns 1, 2, and 3 in this case, we grab the data, and the data is stored as integers. Don't forget, in this particular example, all the data is integers. It looks like strings to the user, but we're only storing integers. We don't want to store loads of strings. So we get the string back, and the string we draw, we use map value. And map value guarantees you'll get a sensible value even if the key isn't there. Now, I think you could argue I should have used operator square brackets, because that would give me a crash if the data was wrong. And that might be a more reasonable solution, because this will give me basically an empty string. And you could argue that a crash would be the more appropriate response, because you want to know that your data is wrong. Yeah? Then I use draw display, which is provided by QModellndelegate. You give it a painter, the option which has various style information, for example, text alignment and so on, the rectangle to draw in, and then a string to draw. Draw focus is recommended by the documentation. Basically, it will do nothing if the item doesn't have focus, and it may draw a focus rectangle if it does. But different items show focus differently. So whether or not it does something may depend on your platform as well. I'm not going to show you the code for Create Editor, because I'll be showing you code for doing that later anyway, except just one brief extract. We create a combo box, and because we don't lay out the widget that we create for editing, we give it an explicit parent, which is the parent we're given. And that means we don't have to worry about ownership. We can new it. Because it's given a parent, Qt will delete it at the right time, and we just populate it with the map. But I wanted to show this particular snippet because it shows a nice feature of the new Q combo box in Qt 4 that wasn't in Qt 3. If any of you used Q combo box in Qt 3, you always had this annoyance that you had data items which were often related to IDs, for example, and there was no nice way of storing them both. Whereas in Qt 4, you can store both. The first parameter is the string that's going to be displayed, and the second parameter is a bit of your private data that's associated with it, which I find extremely convenient, because sometimes you'll have strings that don't map to like 1, 2, 3, 4. As we've got here, we've got different like -10, -5, and things like that. So it's very convenient. So when the editor is created because the user has initiated editing, we then set editor data. And again, the first statement says, I'm only interested in the columns I'm responsible for. Anybody else the base class can handle. Again, I get the data, okay, from the data source, and I make the combo box's current index the one that has the data value. I don't match on strings, I match on my underlying codes. So for example, if those strings were translated, it's not going to be a problem because I'm matching on the real codes. All right? Now, for set model data, that's only going to happen if they accept the edit. It's pretty straightforward. We get the editor, and the only thing that's unusual about this is I'm passing in the Q variant. I'm not converting to an integer. And there's no point because item data returns a Q variant. Model set data takes a Q variant. There's no point in converting to an integer and then back to a variant. I might as well just pass the variant all the way through. Okay, so what we've seen there is, I'll just go back a sec. What we've seen there is a standard kind of delegate, the kind that you would create for your models. And there's nothing wrong with that, and you'll probably create lots of delegates like that. And I don't actually think they're hard to do. Once you've done it twice, you can do as many as you like. You're not going to find it hard because they all follow this same pattern. They're the same methods that you re-implement. And quite often, you don't even have to bother re-implementing paint, for example, because by default, if it's just text, Qt will display that correctly anyway. So it's usually the editor that you're more concerned with. However, what happens when you have lots and lots and lots of models? Okay? Every one needs a custom delegate if you want control over the presentation and editing of your data. And yet, time after time, in all these models, you're going to be editing the same data types. So you'll have a model that has integers and floats and strings here, another model that has integers, floats and strings, and so on and so forth. And the only difference between the models is that this model has its first column as integers and its fifth column as strings, whereas this one has its first column as strings and its second and third as integers. And yet you have to create a custom delegate for both those models because they're structurally different, their columns are different, but the code for handling an editor for an integer, like creating a Q spin box, is going to be the same in both those models. And when you start to get dozens and dozens of models and you're re-implementing the same integer editing and the same floating point editing, you're getting lots of duplicate code. And I think that's bad. Okay, it's certainly not the C++ way, and it's certainly not necessary. We can do better than that. And that is the focus that I want to concentrate on. How do we address that? I would argue that what we need is a single generic delegate that you can set for any view, no matter what the model. Okay? So at the moment, what you do is you create your model, you create your view, and you set on it a custom delegate. I'm saying set on it a generic delegate, the same one every time. And what you do is you customize the generic delegate, not by re-implementing, not by subclassing, but by giving it little delegates that apply per column. Okay? So you might give it an integer delegate that works on a particular column, a text delegate that works on another particular column. And we'll see an example of that as we progress. Now this approach that I'm talking about is something that makes sense when columns are what matters. And that is, in my experience, the most common situation. But then again, I come from a database background, and I'm used to each column is one field and one data type. Okay? So what you would have is your generic delegate, and then you would create a set of data type column delegates, an integer column delegate, a rich text column delegate. And you would set those on the columns that need them. So once you've got one integer column delegate, you don't have to create another one. You've created one, and you can use it every time with every model. Just insert it into the generic delegate for the columns that you want it to care about. So that eliminates the code duplication. First, I'm going to show you the usage. We create a custom model, as always. We use a standard Qt view, as is very common, and we set the model on the view. The next line, generic delegate, we create the generic delegate, will be the same every time. What's different is how you insert the columns. Now, in this example, I've made every column have a different data type, but there's no reason you couldn't have had column 1, plain text delegate, column 2, plain text delegate, column 3, plain. There's no reason you can't do that, okay? So we create a delegate for each of the columns we care about, by specifying the column number and the delegate. And in the case of the plain text and the rich text, there's no parameters. We'll just use them off the shelf. The string list delegate, we actually give it the list of strings we want. So we know that's going to have to show some kind of combo box. For the integer one, we give a minimum and maximum. And for the floating point one, the double column delegate, we give a range and the number of decimal digits to display after the point. Now, those are design choices I've made. That I've made in my column delegate classes. But you, of course, will come up with your own integer column delegate and double column delegate and so on that suit your data. You might, for example, for your integer column, double column delegate, you might specify a currency symbol, for example, as a prefix or a suffix. So this is very versatile. If you imagine now we had another model and another view, we would create a generic delegate, and we'd set column delegates, just as we've done here, but they would be different column numbers, different column delegates to reflect the needs of that particular model. But again, we're avoiding the code duplication. And if you think, I found that basically I had 3 models, and they had many common data types, and they required about 150 lines of code to do the 3 custom delegates. And I got it down to 30 lines that just looked like that, just 3 lumps of that, and it was done. Okay, so I do think it's a powerful technique. So here's the example. The first column, and this is the example that came out of what we've just seen. The first column is read-only, the second is plain text, the description is rich text, and I'll show you how to do display and edit rich text in an item as part of this talk, because I think that's a bit of fun. The category doesn't show as a combo box, but if you initiated editing, you'd get a combo box with just the items in the list that we set. And quantity and weight are respectively a Q spin box and a Q double spin box when it comes to editing. Okay, so that's the principle and that's how it's used. Let's see the implementation. And I think the big shock about the implementation is this is not hard at all. The generic delegate in particular is very simple because basically it does very little work. Structurally, it follows the same structure that we've seen before time and again. It is an item delegate subclass, and we'll see why it needs to be later. We've got our normal 4 methods, but in addition, we've got a destructor. We're going to do something in the destructor. And we've got 2 other methods, insert column delegate and remove column delegate. The only reason for remove is just for completeness. I can't think of a use case, but I'm sure some of you might. And the other thing about this class is I've done it in Qt style. You insert things into it. As we saw, we newed our column delegates on the previous slide. When they go into this, this takes ownership, which is why it's got a destructor. So you don't have to worry about the fact you've newed all these column delegates. This is going to take care of them. And of course, this is owned by the view that it's set on. In the very last line, we do set item delegate, and that's the generic delegate. So when the view is destroyed, it will destroy the generic delegate, and the generic delegate will destroy all of the column delegates that you've inserted. Okay. And the only information we need to store is a map that tells us what column number, for a given column number, what's the abstract column delegate. Okay, so that's pretty straightforward. I could have used a hash, of course, because I don't need any ordering. Okay, so I'm going to look at the destructor and the insert because they're kind of related. The destructor, I think, should be unsurprising. We just iterate over all the delegates we've got, which could be none, because you could create a generic delegate and set it, and you'll get exactly the same behavior as you had before with a QItem delegate. Okay? It gives you this extra facility that you can designate particular column delegates if you want to. So the destructor cleans up for us. The insertion is slightly odd looking, perhaps, because we begin by deleting things. But again, we're using QMap value. Now, what that means is, if there isn't a column delegate for the column we're setting, we'll get a 0 pointer back, and deleting a 0 pointer is harmless and not terribly expensive. But we have to do this because we've taken ownership. The generic delegate owns its pointers, so it has to make sure it deletes them. I'm not going to bother showing remove because the code's easy, and the source code for this is available, and I'll tell you about that at the end. Okay. So, painting. This is the only method I'm going to show. There are 4 methods. There's paint, there's set editor, and so on. This is the only one I'm going to show because all the others are basically the same. The first thing we do is say, what is the abstract column delegate for the column you're asking about? Okay? And there's 2 possibilities. There is one, it's been set, in which case we get its pointer and we say, delegate, column delegate, you do the work. The other possibility is it hasn't been set, in which case we say, subclass, base class, you do the work. So the generic delegate does nothing itself. It just passes on work. It passes the buck every time. So all the other methods are structurally the same as that. They get the column delegate or a 0 pointer, and they give it to the delegate, or they give it to their base class implementation. That is the whole story for a generic delegate. So what we now need to do is look at, well, what are these abstract column delegates that we're setting? And I hope that by now it won't be any surprise. It's another QItemDelegate subclass because we're implementing the same 4 methods. Now, I've made some design choices here. I've decided to implement the paint function by default, and I've made the other functions pure abstract. Now, that is extremely debatable. You might not like that, and there's no reason you should. You can change that to suit yourself. But they happen to suit the way I was thinking at the time. So an abstract column delegate is so far no different from what we've seen before. And if we look at the code, I'm going to show you the code for one particular one, because obviously I could show you the code for an integer one, a double, a date one, and so on and so forth. But they're all structurally the same. So I don't think there's value in showing you multiple versions of the same thing. So I'm just going to focus on one. And the one I've chosen is the RichTextColumnDelegate, mainly because that's prettiest, because you can have colors and fonts and things like that. And also because it actually shows some interesting things that do not apply to any other delegate. And that's why I thought this was a especially interesting one. Now, the first unusual thing is that this thing has a label. The other unusual thing is the label is never, ever shown. Okay? We just create it, we never show it. And I'll explain why as we get along. And in fact, you could in Qt 4.2 use a Qtext document, but I chose to keep it as a label because I wanted it to be 4.1 as well as 4.2. So what's a RichTextColumnDelegate got to do? Well, it's got to be able to draw or paint rich text. So we're talking about, in Qt terms, rich text is HTML. So it's got to be able to understand font tags and bold tags and things like that. It's also got to let you edit rich text, but Qt doesn't have a one-line edit rich text editor. But that's okay. We can inherit QTextEdit and chop it down a bit, and that works fine. Okay, I'm not going to show you the source of that, but it is available. I will make it available to you so you can see how it's done. It's not hard. Okay, so the constructor does something not exciting, but very important. Creates this label, so there's only ever one, and it says whatever text you're given is rich text. Treat it as HTML. But there is a problem, and the problem only applies to this. It doesn't, for any other column delegate you create, this problem does not apply, okay? And the problem is this. When the view says to the model, what is the size hint for this item, the model calculates the size hint based on the current font and the data. Now, if the current font is Helvetica 12 point and the data is hello, that's just 5 characters, and it'll work out the font metrics, and it'll give you some number of pixels, and that's fine, and that will be correct. But with rich text, if you look here, we've got, I think they fiddled with my slides. if you look from the beginning there, we've got a tag, font color blue, blue text / font. Well, that will only display the text blue text, which is 9 characters. But the font metrics are going to be for a 35-character long string. So when the view asks, what's your preferred size, it's going to say, I need that much space, when actually it only needs that much. This is the only exception to the rule with the column delegates. So the solution is quite simple. If you remember from earlier, we showed looking at various roles in the data method. Well, there is a role called the size hint role. And all you have to do in the size hint role is say, OK, strip the HTML, the tags, and just do the font metrics yourself on the text that's left. And that works fine. OK? It works fine on Linux anyway. On Windows, I found it a bit tricky with 4.1. Oh, yes, of course, of course. But if the question was, what happens if you set a large font in the HTML? But we're talking about one line of text. And in my rich text line edit, I don't allow the user to create bigger fonts because I don't think it makes sense in that context. But you could, and then you'd have to account for that. You'd have to take the font metrics of the height, and you'd have to do some parsing. And that would be hard, but not impossible, just hard. And I'm not convinced necessary. OK. But please bear in mind, OK, for rich text, you have to do the size hint. But it's the only case I've encountered where you do. OK. Now, the paint method is, again, I think, interesting, more from a fun point of view than anything else. What do we need to do in a paint method? Well, we need to get the text to paint, which is what we do on the first line. And what I found through practice is that I needed to color the background depending on whether it was selected or not, and I needed to do that myself. And as we know, Qt loves giving you color control. So I created a palette from the label, because the label is the thing I'm doing all my painting on. I set the background color, which is called QPalette::window, depending on the state of the selection, and then I set the palette back on the label. The next step is absolutely critical. I say to the label, you are a fixed size. What size? The size that I've got for my rectangle in my view. And that size is given to us. I've got to make it the right size. And then I set the text on the label. And if you remember, we've told the label, any text you get is HTML, treat it as such. So the label will parse the HTML because I didn't want to, and it will lay it out and do it beautifully. But then I've got to get this label onto the screen. So there's a static method in QPixmap called grabWidget, and what it does, it says, given a widget, draw yourself on the pixmap I give you, okay, and return that pixmap. So I just tell the label, draw the rich text so that I don't have to bother with all this parsing stuff that's hard. Give me the pixmap and draw it in this rectangle. Job done. It's that easy. And it works beautifully. And now some of you may say, oh, but isn't that inefficient? Isn't that going to cost us? But this is the thing. This is happening in the user interface. How many items could you display on a screen, even a 21-inch screen? Thousands? Yeah, sure. Thousands isn't going to be a problem. Millions would be a problem, but you can't display millions. So the performance doesn't matter. Your user's never going to know. It looks beautiful, and it works really nicely. So it is a trick, but I quite liked it. And that's why I wanted to show this particular column delegate. The next two bits are not exciting, but they show you the pattern. And they also give me a chance to sort of make a complaint, because I know some of the model view trolls are here. When we create the editor, we create our rich text line edit. As I say, the source code's available so you can see what that is. But it's basically a QTextEdit subclass. Then we have to do this install event filter thing with a horrible const cast. Now, that is in the documentation. I've copied it, to meet the documentation. But I don't particularly like it, and I've actually found it didn't make any effect, certainly on Linux, and certainly with Ming W on Windows. But I still put it in there because if the docs say that, I've got to assume it does do something and is meaningful. but I wish I didn't have to. The set editor data, again, that only is called if the user confirms the edit. So what happens is we get the data and we put it in the editor. But we have to use set HTML because this is a Qtext edit subclass and it has two methods for putting in text, set plain text and set HTML. And throughout we're dealing with HTML here. So that's why I've used that method. Okey-doke. Set model data, dead easy again. I mean, I'm assuming you're familiar with QObject cast. It's basically like dynamic cast. Okay, it will give you 0 if the thing isn't of the right type. I don't check for the 0 here because I'm the one creating the editor. I'm the one who's getting that same editor back. And this is another example where I'd rather have a crash if it's wrong, because I want it just to fail, and then I know there's a problem in my logic. An alternative would have been to put in an assert, of course. Now, when we set the data, I could have used 2HTML, which is provided by QTextEdit, but I've actually implemented my own 2SimpleHTML method because I know that with a one-line editor, I'm not going to have tables, lists, and lots of other things, so I can write quite compact HTML, so I prefer to do that. Okay, so I've gone quite fast, faster than intended. So I hope I haven't, rushed it too much. The key, I think, for this is if you're creating lots and lots of models and you're using the same data types over and over again, integers, dates, floating point numbers, rich text, plain text, over and over again, and that the only difference is which columns have which data types, then this allows you to create one column delegate for each data type and then to construct delegates which are specific to your models by creating a generic delegate and populating it for each field with the delegate that's required. And I think that will save you a lot of duplicate code. And also, of course, it's easier from a debugging point of view, because if you've made a mistake in one model, then are you going to have to replicate the fix across loads, the custom delegates for all of them? Whereas with this, if you mess up your rich text delegate, you only have to fix it in one place. Okay, you do a lot of rebuilding, but still it's only one fix in one place. So I think it's a nice technique to use. And in general, I think that the model view architecture is really good, as long as you get your head around it, because that's, and I think the key to that for me is distinguishing between lists and tables, which work directly on rows or rows columns, and trees, where you have to think recursively and indirectly in terms of parent and children. There are different ways of thinking. You have to separate those out. But it doesn't matter for a generic delegate point of view. Works with both perfectly well. Okay, so I've gone faster, and I'm sorry about that if that's been too quick for you. So I better open it up to questions.